In this video we're going to do an unpaired students t-test. So this compares the means of the two different groups of individuals and determines if the mean is significant. So the mean is the average of the data set. So this is how you calculate the t-value. Use the means, the standard deviations and the numbers. For the purpose of the standard deviations and the means, we're going to use this calculator. You can do it manually, it just takes a bit longer. And I'm too lazy to. So this test is used when there are two categorical groups. They don't have to be the same size, as shown in the example we'll do later. They're from different individuals, so it can be independent data, and they're interval data, so it's measured on a scale with unit steps, so like discrete variables. So we're going to do a degree of freedom analysis as well, because we need to look on the data tables our critical value. So it'll be the number in set 1 plus the number in set 2 minus 2. So if the value of t is greater than or equal to the critical value, the difference between the two means is significant and the null hypothesis can be ignored. So we'll go over the null hypothesis once we've started the example. So we've got an example here. An investigation is done to examine the effect of a high sugar diet on the body mass of rats. 15 rats are divided into two groups, 7 in the control and 8 in the other group. The control group is fed a normal diet and the other group is fed a high sugar diet. This lasts 2 months. The rats were weighed before and after the experiment, and it gives us the critical value at 13 degrees of freedom is 2.16 at 5% significance. I've added this in because I haven't printed off the data table which we would use to calculate and look up the critical value, because it's I just haven't printed it off. So if we look at the null hypothesis, so the null hypothesis is that there is no significant difference between the mean, right, because we're looking at the means with unpaired student t-test, between the means of weight gain of the rats on normal diet compared to the mean of the rats on the high sugar diet. So now that we've got our null hypothesis, the alternative hypothesis is that there is a significant difference between the mean weight gain of the normal diet compared to those with the high sugar diet. So our critical value up here will tell us whether there's no significant difference or if there is. So for our example, we've got data here. This side we're given a set of data with the weight of the rats on the normal diet and the weight of the rats on the high sugar diet. We have copied the equation here for the t-value. So we need to find out the means of the data sets. I'll refer to this as group 1 and group 2. They identify by the group or by the subscripts. So we need mean, standard deviation and the number. So the number in group 1, 2, 4, 6, 7. The number in group 2, 2, 4, 6, 8. As per the question. So now we need to calculate the mean and standard deviation. I'm going to do it using the calculator. Go to menu, statistics, one variable, and then we put in all our numbers. So 102, 96, 113, 89, click Option and Option 3, One Variable Calc. And we have the mean as 103.14. The standard deviation is this one, 9.41. Then we do the same for group 2. So we have 145, 163, 153, 159, 149, 168, 172, 183. So then we do options, one variable calc. We have a mean of 161.5 and a standard deviation of 12.67. So now that we've done that, we can return to our normal calculator, and we can calculate the t value. So it's the mean of group 1 minus the mean of group 2. So that's minus by 161.5 divided by the square root of 9.41 squared divided by 7 plus 12.67 squared divided by 8. So that equals 103.14 minus 161.5 divided by 9.41 squared over 7 plus 12.67 squared over 8. That gives us a value of negative 10.2. Now, because the mean, I'll just write that down, negative 10.2. Because the mean of group 2 is higher than group 1, that's the only reason why the t value is negative. And we assign the groups randomly, so this could have been group 1 and this could have been group 2. So the value of t as minus 10.10 is equivalent as if it was positive. So with a value of positive 10.2, we can write a statistical conclusion. On the previous page, we were given that to calculate the degrees of freedom was the groups plus each other minus 2. 7 plus 8 is 15, minus 2 is 13. And the critical value at 13 degrees of freedom is 2.16, 5% significant figures. So we're going to compare that to our t value and write a conclusion. So the critical value at 0.05 or 5% probability was 2.16. So our value of 10.2 is more than 2.16. So the difference is significant. Remember on the first page, when it explained here, if the value of t is greater than or equal to the critical value, the difference between the two means is significant and the null hypothesis can be rejected. So we'll work that into our conclusion. The critical value at 0.05 probability is 2.16. 10.2 is more than 2.16. So the difference is significant at this level because the critical value changes depending on your significance level. So if we work into account the hypothesis, this means we accept the alternative hypothesis, i.e. reject the null, that there's a significant difference between the mean weight gain. of the rats. Can be very specific, of the rats on the normal diet compared to the high sugar diet. So we basically wrote our conclusion comparing the critical value and the t-value, and we've also stated which hypothesis we are accepting and rejecting. And that's it. That's how you do the unpaired students t-test.